Hey everyone, Mr. Eder here. If you didn't already know, I have been quarantined, like many of you have been quarantined, or are currently, and so we're gonna make it through this week together. It'll be an interesting week, but I plan on recording a lot of the lessons. I will also be live in class at the beginning of every class. Today we are talking about Bohr models and valence electrons. If you are in cohort A, that is Monday the 28th. If you're cohort B or an e-learner, that will be Tuesday the 29th. So today you need to complete the Bohr models and valence electrons. You also need to complete the exit ticket. Sorry, I did not put that on there, but there is an exit ticket for you to complete. If you are at home, there is a light and waves ed puzzle to watch that talks about electrons and how light is emitted from atoms. So let's get to Bohr models. The purpose of Bohr models is to show the amount and the location of all three subatomic particles. Remember, the subatomic particles are the protons, neutrons, and electrons. So this should be a little bit of a review lesson today. But let's go ahead and go through how we build Bohr models, and then we'll put it all together at the end. When we create Bohr models, there is a nucleus, and that nucleus contains both the protons and the neutrons. So we write the number of protons and the number of neutrons in the middle of the Bohr model. So you see where it says nucleus on the right side over here. You see where it says nucleus? That's where we will write the number of protons and electrons. So this is how we would do that. So for example, if we take lithium 7, look on a periodic table, find lithium, and you will see that its atomic number is 3. So lithium has 3 protons. Lithium 7 means the mass is 7. And so if we have 3 protons, then we must have 4 neutrons because the mass is 7. So the protons and neutrons go in the middle. Now let's focus on electrons after we do this example. So another example, calcium 41. Find calcium on the periodic table. It's on the left side. Calcium has an atomic number of 20. Calcium 41 means the mass is 41, and so the protons plus the neutrons equals that mass, so there must be 21 neutrons. Okay, so now to the electrons. The first ring of the Bohr model can hold up to 2 electrons. So we could put one there and one there. It's helpful if you group them together in pairs, just so it's easier to look at, and I always start by putting them on the top. But the first ring can only hold 2 electrons. From there, we get to the second ring, and the second ring can hold up to 8 electrons. So we could put one on top and one next to it. Then I move to the right side, 3, 4, move to the bottom, 5, 6, and move to the left side, 7, 8. And now the second ring is full. The second ring can hold no more electrons. When we get to the third ring, for our purposes, the third ring can hold up to 8 electrons. Okay, it can actually hold more than that, but for our purposes, it can only hold 8. We're not going to get into why, but just understand that it can hold more, but we're not going to worry about that. So we put another 8 electrons, 1, 2, 3, 4, 5, 6 on the bottom, and 7 and 8 on the left side. Again, it's helpful if you keep them organized that way. It's not a requirement, it's just helpful. Then there's a fourth ring, and for our purposes, the fourth ring could hold up to 8 electrons as well, although we will never have more than 2, so I just put 2 on top here, and that would be the largest Bohr model you would need to make, where there's 2 electrons on the fourth ring. One thing to note that the Bohr model does well is it shows us the amount of valence electrons. The valence electrons are all the electrons that are on the outermost ring or the outermost energy level of a Bohr model. And the reason that's important is the valence electrons help determine the chemistry of the atom. They tell us how they are going to interact with the other atoms. So let's put this all together. Let's draw the Bohr model for boron 9. So the first thing you should do, find boron on the periodic table. You will see that its atomic number is 5, so I would write 5 protons. The mass is given to you, boron 9, so that means there are 4 neutrons, so 5 protons, 4 neutrons in the nucleus. And then we need 5 electrons. 1, 2 on the first ring. We need 3 more. 1, 2, 3. We get 3 electrons on that second ring. Okay, there are 5 electrons because it's neutral, right? 5 protons, so there's 5 electrons. Protons and electrons are equal when it's neutral. So how many valence electrons does boron 9 have? Well, it's the outermost electrons. So 1, 2, 3. There are 3 valence electrons. And lastly, let's write the isotope notation for boron 9. What would that look like? It would look simply like this, where the mass, remember, is in the top left corner of the symbol, so the symbol B, and the mass 9 on the top left. When we do this again next time I see you on Wednesday or Thursday, we'll be looking at ions and the formation of ions. And so this isotope notation will look a little bit larger. So next time, make sure if you are in class today, cohort A, you do the light and waves ed puzzle tomorrow. If you are cohort B or the e-learners, you will be doing Bohr models and ions, as I just explained. Thursday, we will be looking at Bohr models and ions in depth and how do ions form. So today, please complete the Bohr models and valence electrons worksheet. And the exit ticket. There is an exit ticket. Please email me if you have any questions. That is our lesson for today. I will stay on for a little bit longer if you have any questions.